our lesson today about exponential growth and decay. Exponential growth means if we have the rate of change of x according to the time t equals constant k times x initial value of x. So the rate of change depends on the value of x. If we separate this equation, we get dx by x equal k dt. By integration both sides, we get ln absolute of x equals k t plus c constant. So x may be equal kt e power kt plus c, or negative x equals e power kt plus c because of absolute of x. This means in x equals e power negative kt plus c. Negative here refer to decay, and positive k refers to growth. So x equals e power kt plus c. K may be positive or negative. The formula for find x at any time by growing or decay. This formula, we need it to find x at any time continuously. So what is the difference between this formula and the formula we have before? X equal x dot plus 1 plus or minus r over k to the power kt. This is our problem to solve. Now, this formula e over kt plus c, we have here two constants. One is c, another is k. To find c, we put t equals 0. At t equals 0, x equal x dot. This means equal the initial value of x. X dot equals e power k times 0 plus c. This means x dot equals e power c. So this formula become x equal x dot e power kt. What about the another formula? Another formula, x equal x dot 1 plus or minus r over k to the power kt. We learned before limit k tends to infinity. 1 plus or minus r over k to the power kt equals e power kt. So this value, if k tends to infinity, becomes this value. What is the difference? The difference here, if the value of x continuous growth or decay, this allows this rule. But if k is discrete, okay, here means the interval at k equals 1 year, 2 years, and so on. If we talk about the number of bacteria growth or number of half time of radiant metals, we can use this formula. This formula means T is varies continuously. If we talk about the insert of money, about year, 2 years, half year, we can use this formula. Now we take example about this. Suppose you deposit $800 in an account that pays 6.3% annual interest. How much will you have 8 years later if the interest is initially compounded continuously? B, compounded quarter. In this example, A dot equal $800, R equal 0.063, 6.3%. The amount in account to the nearest cent after 8 years, T equals 8 years. Number A, compounded continuously, means we use this formula. X equal X dot E power KT equals X dot 800 E power K 0.063 K or R times 8. This approximately equals 1324.26. Number B, compounded quarterly. Quarterly means there's 4 inserts in 1 year. 4 times the insert become. So A of 8 in this case equals 800 1 plus 0.063 over 4 or power 4 times 8 equals approximately equals 1319.07. We can compare between two values. This value is greater than this value because of the value here continuously. At any time we can find X, but here at the time of the end of 8 years we can find this amount of money equals 1319.07. As the previous example, we use two formula. The first one, X equal X dot E power KT, and second one, X equal X dot 1 plus R over K to the power KT. This formula, we use it in grade 10, and we use this formula in grade 12. What is the difference? Here K equals 4. So we have 4 interval in 1 year. 4 interval for 1 year. If we not reach the end of year, we have by 1 hour or 1 day, we have 3 intervals only. So the year here is divided into 4 parts. The first part, second part, third part, fourth part. If we stand here at this point, this means we have the insert of money at 3 intervals only, because we don't reach the final or the end of year. The end of year here. If k tends to infinity, this means we have infinite number of intervals. This means we separate or divide the year into infinite number of points. At any point, we can find the answer at this point continuously. At this point, we can find here or here or here. Not care about what's the interval. What is the interval number? Here we can, if we stand here, we get one and only one interval. And here we get two, and so on. Here we can find the answer at any point. So we use this formula to find the number of bacteria, number of virus growth or decay, because the rate of change here continuously. Another example, find the half-life of radicative substance with decay equation y equal y naught e power negative kt, and show that the half-life depends only on k. Y equals y naught e power negative kt. This equals half y naught, because this equals the half-life, half of initial value of a of y. If we omitting y from both sides, we have e power negative kt equals half. By getting ln e power negative kt equals ln half. So negative kt equals ln half. T equals ln half over negative k, or negative ln over k. Negative ln half equals ln 2 over k. Remember, negative ln half equals ln half to the power negative 1. This equals ln 2. So t here, the time, not depends on y dot, but depends on k only. Ln 2 is constant. So t depends on k. What's k? The coefficient of rate of change. dy by dt equals ky. So t here depends on k only. Bacteria growth. A colony of bacteria is growth under ideal conditions in laboratory, so that the population increase exponentially with time. At the end of 3 hours, there are 10,000 bacteria. At the end of 5 hours, there are 40,000 bacteria. How many bacteria were present initially? Y equal y dot e power kt. We need this formula because the bacteria growth is continuously. Y3 equals y dot e power 3k equals 10,000. Y5 equals y dot e power 5k equals 40,000. This is equation number 1 and number 2. If we divide 2 by 1, we get e power 2k equals 4. So 2k equals ln 4 and k equals ln 4 over 2. Ln 4 divided 2 equals 0.69314. To find y naught, we can substitute k in equation 1. y3 equals y dot, we need e power 3 by k 0.69314 equals 10,000. So y naught equals 10,000 divided by e power 3 by 0.69314 or 5 approximately. 10,000 divided by e power 3 by 0.6315 69315 equals 1,249,098,9 approximately equal 1,250 bacteria. This means initially we start with 1,250 bacteria.